In the last video of this section, we just want to go over some of the theory of derivatives. Okay, so we say a function is differentiable at an x value a if the limit in the definition exists. Okay, so if the limit as h goes to 0 of f of a plus h minus f of a all over h. Okay, so if you can take that limit and the limit exists, this is why we spent all that time learning about limits, then we say the derivative exists there at a. Okay, we say a function is differentiable if its derivative exists at every point, or we can say every x value in its domain. Okay, so we're going to talk about some places where functions aren't differentiable, but if it's differentiable everywhere in its domain, then we just say the function's differentiable. Okay, and one more thing, and we'll see that this is true. If it's differentiable at a, then f of x must be continuous at a. So we've talked about, in Unit 2, we talked about what it means for a function to be continuous. If you're differentiable, you must be continuous there. Now, what this does not mean is that if you're continuous, you have to be differentiable, okay? We will see places where we're continuous, but we don't have a derivative, okay? And here we're going to see a few places where we're not differentiable. The first one would be what's called a corner. So if we have a sharp corner like this, if this is our function, okay, then at x equals 0 here, we wouldn't know what the derivative is, because remember, derivative means the same thing as slope. And as we came from the right-hand side at 0, the slope here would be something positive. Say it would be 1. But as we came from the left-hand side, it would be something negative. So there at 0, the function would not have a derivative. Okay, very similarly is what we call a cusp. And it looks kind of like, when you first learned how to draw birds and you just drew little V's. If you have a point there, similar to a corner, on either side, the slope is doing something different. Okay, the next one's when we have a vertical tangent, and that's when the tangent at a point, so at this x value, goes vertical for a minute. And we'll see some examples of this in the lab. But remember, vertical lines don't have a slope, so we can't talk about a slope if the tangent is vertical. And then our theorem above said that if we're differentiable, you must be continuous, which means any place where we have a discontinuity, whether it's a vertical asymptote. So if you had something like this, at that vertical asymptote, you don't have a tangent. If you have a jump discontinuity, or something like that, at that point we wouldn't have a derivative. What other kind of discontinuities did we have? If you have a hole, you're not derivative, or you don't have a derivative there. So any place where you're not continuous, you also don't have a derivative.